Alrighty, welcome. So we are going to do a little activity here. And what you're going to need to do this activity is a pen, paper, and calculator. So pause it, go get it now. For real, I'm going to wait, go get it. All right, so this first problem, what I want you to do is you're going to enter the number 1, and you're going to multiply that by the number 10, right? So 1 times 10, you guys are all high school students, so we know that's 10. So we're going to take the number 10, multiply that by 10. So you get that answer. You're going to take that answer, multiply it by 10 again. And we're going to repeat this process a few more times. So keep track of where we're at. Times 10. And do it a 5th time times 10. We're going to do it a 6th time, a 7th time, an 8th time. Keep going. Don't lose me. A 9th time, 10th time, 11th time, and a 12th time. What I want you to record is what does your calculator give you as an answer right now? All right, write it down. And we're going to do another problem. So you're going to do the same thing, but kind of in reverse. So you're going to take make sure your number's cleared. Take the number 1, divide it by 10, aka 1/10. And you're going to divide that by 10, and divide that by 10, and divide that by 10. Keep doing this for real on your calculator. This is partially so you know what your calculator is going to look like when you do these type of calculations. So if you're using a regular calculator, the one on your phone, a scientific calculator, they all display things a little differently. So if you didn't figure it out, we're going to do this to 12 places again. And now write down your answer. Okay. If my clicker, there we go. Alrighty. So this formation we just did, if you wrote it out on a piece of paper, looks like this. So 1 times 10 times 10 times 10 times 10 times 10, blah, blah, blah. This is a pain in the butt to say, let alone write out. So if you punched it in your calculator and your calculator screen was big enough, it would have read 1 billion. Your calculator might not have read this. We'll show you what it might look like in a minute here. But if we count out each of those tens, we already know this from, there was 12 steps. So there's 12 tens here. But you can count out the zeros, and essentially what you did was shift that 1 down a place. So you went from the ones place to the tens to the hundredths, on and on till you got to the billionth or billions place. So 1 times 10 to the 12th is the shorter way to write this. So I'm sure you guys have already done exponents. What you might not have been familiar with is if your calculator displays an E, it's trying to show you essentially the same thing. That E is just saying it's an exponent. So 1 to the exponent of 12 is going to be this, okay? And kind of you might just naturally know when you multiply something by itself a bunch of times, that's an exponent. What do you call it when you divide something by itself a bunch of times? And we know that we got a billion when you did this divided by, you got something small. And when I said 1 divided by 10, you already know that's a tenth. But if you repeat the process, you get a billionth. So it's literally the same thing in reverse. So the exponent is going to be 12, but this time it's going to be negative. And same thing with that E. It'll be E to the negative 12. All right. This is called scientific notation. When we're doing big, crazy calculations throughout the year, this is the kind of writing we're going to use to keep track of stuff. It saves a lot of space, mainly. So you can write any number in this form, big or small. So one of the ones I want you to pay attention to is this guy. We're going to come back to it here in a second. But if you wanted to write a million, right, that's 1 times 10 to the 6th because there are zeros. You moved the millionth. Now, the thing that trips everybody up too is, right, there's a ones place, but there's no oneth place, right? The first time you move it over, it becomes the tenths place. So when you look at it, instead of having 6 zeros, because you had to move the decimal over that 1, it's actually going to be 5 zeros and the 1 to be a 1 millionth. Okay? All right. So I have a sheet with this definition written out for you. This is the sheet you should be doing some of this work on just to keep track of your own notes. But scientific notation is the way we express very large or very small numbers. You can even just do regular numbers, and there's an advantage to that later we'll talk about. A very small number is written as a negative exponent, just like we said. So we're going to look specifically at this whole negative exponent moving to the left and this positive exponent moving to the right. So my clicker's not working. Sorry for these pauses. So our earlier example, when we were looking at this, we had 1 times 10 to the 12th. This is the same as writing out 1.00000. So we don't have to write all these placeholder zeros out every time, but you know they're there in the front and in the back. They're just holding the place. But in this example, when we do 10 to the 12th, we know we need to move it to the right to make it a bigger number. So you would just count out from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you would fill in these zeros on your paper as you did this, and you would come up with the number 1 million. So just like moving those arrows, count as you go. Same is true for that negative 12. Just to look at it, this is the same as taking 0, and we don't have to write out all the zeros because what we're going to do, we know there's a decimal point here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Put a period there. We could fill in all these zeros, and you're going to end up with this, which is 12 zeros minus 1 because we had to go over that 1 spot, right? So we know that this is going to have 11 zeros, point 11 zeros to the 1. So that is the 1 billionth. Okay. Now, I want you to think about this in reverse. If we took a billion and multiplied it by 10 to the negative 12th, what answer would you get? So if we did our decimal moving trick, you're going to move this 12 places and you should end up at 1. And if we just talked about this, 1 billion, another way to write 1 billion is 10 to the 12th. So that means if you multiply 10 to the 12th by 10 to the negative 12th, you get 1. Now this should be setting off some little alarms in your head. For anybody that doesn't remember from your math classes, when you multiply exponents, you can add them together. So that means 12 plus negative 12 equals 0. So this is the same thing as writing 10 to the 0, which equals 1. Alrighty. So again, this might start confusing you a little bit. Feel free to go watch this again, but I'm just going to give you another variation. I want you to be able to move between each of these versions as you do some of these calculations. So when you're doing your work or checking your work, you can kind of follow what we're doing. So 1 times 10 to the negative 12th is the same thing as saying 1 divided by 10 to the negative 12th. And that might not feel very obvious until I show you the normal fraction form of this. So 1 trillion divided by a trillionth. 1 divided by 10 is a tenth. We know that. So, and we already said that this number is equal to this number. So 1 divided by that number. So what I'm trying to show you here is that these exponents are interchangeable. So just like you can add those exponents together when you are multiplying, when you divide, you're going to subtract them. And you can interchange them this way. So 1 divided by a 10 to the negative 12th is going to be the exact same thing as that. And again, that might feel even weirder, but when you look at it written down, if you take 1 and divide it by a very, very tiny number, you're going to get a very, very big number. It's the exact same thing in reverse. So keep track of this. This will come in handy. And we're not always just going to be using the number 1. We might be using larger numbers or smaller numbers when we're doing our calculations, or your answers might come out to be not 1 point something or whatever number, 8 point something. But in this example, 1.3 becomes 1,300,000 when you multiply it by 10 to the 6th, because you're going to move that over 6 spots. So let's practice this a little bit. And I want you to let you know there are some worksheets. You can get as many as you want. I have a bunch of variations to try these on your own, but follow along with me on this one now. So 7.478 times 10 to the 6. It's just like the one in the last problem we just talked about. So you know you're going to move it to the right, and this is why you want to do this on paper 6 times, because you would just rewrite this in a space where there was space. But we know we're going to add 3 zeros to this. So it's going to be 78,478,000. And on this one, go ahead and try it. Now, what some of you might have ended up with is 82.3649. And I'm going to tell you that's wrong. I tricked you. So remember, you have to pay attention to these divided signs. It makes those negative positive rules flipped. So when you divide by it, it's the same thing as if we multiplied by a negative exponent. So we know when we multiply a negative exponent, we have to move it to the left. So when you divide by a positive exponent, you also move it to the left. Okay, keep track of that. Now this number is really, really big. A way that might make this a little easier is if you just played with the factors. So you're going to figure that out on the next exercise.